Welcome back to Triplicate, and today we are going to move on with our boat speedometer project, which, as you can see, is still essentially a picture, and we've been going through the various I guess modules, subsystems that we're going to use with it. We've done the GPS and we've done the Bluetooth, and today we are going to look at, can you see that? Of course you can't. That is an SD card reader, and we're going to use an SD card because once we've got a GPS on to use the position to calculate the speed, we might as well log where we are, and we're using an SD card to log it on, and then we've got the Bluetooth which we will use to get it off the to get the logs out and hopefully do some settings, any settings that are needed, without having to drill any more holes in the box than are necessary, because it's going to live outside in the weather, so it will get rained on, believe me. Okay, so here we have our Nucleo board, and here we have our SD card interface, and if I hold that up you can see it talks about Mozzie and MISO. So it's an SPI interface, so we've got to connect that somewhere onto an SPI on here, and we are also going to connect an FTDI board so we can get information in and out, just connected to the computer and have a little app on the computer, and that's going to take a bit of wiring, which I am going to just get on with off camera. Right, worked out my connections for the UART for this and the SPI port for the SD card. Have connected the FTDI board up. So I'm going to start with that using a new API driven FTDI, and I am going to get that working and then worry about connecting up the SD card and getting that working. So I shall now go away, I guess, and write some code for this and for the PC to talk to it. Okay, so this video is straight after the one where I got the FTDI API working and realised I'd got something wrong. So here we have, for now, just the FTDI interface with the RX and TX linked together, so anything you send out of the out comes back into the in, out of the TX comes back into the RX. And what I was finding was happening is it was hanging up on the read, on the FT read function, and I went into the datasheet and found if you give it the FT read function a buffer and the size of the buffer, it will wait in the function till it's filled the buffer, which is not what we want to do, because if it's not getting anything, the code will hang up. So what we need to do is get FT get status, which will tell us how many bytes there are ready to be read, and we read that number of bytes, so the function will, the FT read function will return immediately. So whoops, I'll have to update the description on the FTDI API video. Anyway, just a little heads up on that one. Okay, here it is working. Right, opens it automatically. Loop back. There you go, right. Just loop at tick count, I'll go into that in a bit. And another one, right, and another one. And you can see the RX and TX LEDs blinking on the board. So far so good. So now can we send data to and from the Nucleo? Right, okay, so got the serial running and not going to use up a load of video time with that. Done that in other places. Basically I pinched the code out of the mean green MIDI interface, serial code, you see what I mean? So let's just have a real quick look at that. So here is the PC end, so we will hit run. Okay, FTDI, loop back, just test the serial, and there we go. So it just says write, that's the PC writing, loop is the command, and then that's the PC tick count is 272, and it gets back a similar loop command, and it tells you the STM tick count, which is that big number, and the PC tick count when it received the original message. And this is going to be my message format. It's going to be 4-letter command, an at, and then a text string, and I am going to use text strings entirely throughout, which is a bit clunky, but the SD card has 2 gigabytes on it, so I'm going to fill it up with an awful lot of text, being as the GPS takes 1 reading a second. Right, let us get on to the interesting bit and start trying to talk to the SD card. Okay, so this is how I set up. You can use SD cards in an SPI mode, so I was going to do that using SPI do, and here you see I've assigned the pins for it, and the Cube IDE helpfully provides a FatFS, an FAT file system middleware for you. So let us look at that, but unfortunately if we do that, it says SD card here, yes, but greyed out. So the usual trawling around forums, I discovered that actually we don't want to use the SPI interface, we want to use the SD for the SD card I/O, and I originally tried on MMC 1-bit, we want to use 1-bit because our little card is only a 1-bit interface. We'll look at that in a minute. So there we go, we set it to MMC 1-bit. So we go back to our FatFS, whoops, still no SD card. And you can imagine this took me more than it's taking me to tell you. But if we go back to the really basic SD 1-bit mode, we get FatFS SD card, yes. There we are, and I got a clock problem, and it kept popping up boxes saying clock configuration error. So we go in the clock configuration, and eventually it's somewhere down here to this one, and some of these were in red. And it kept, and then it's got to resolve clock issues nicely. So I resolved the clock issues and it was happy. Just if you get that, you need to go into clock configuration and resolve clock issues, and it'll sort it out for you. So shall we? Away. Project build all and see if it'll build, and then we'll have to see if we can alright, so it doesn't like that. Do you want to still FatFS verify platform settings tab? Okay, no, we don't want to build. We will go into the FatFS platform settings tab, detect SDIO. Okay, a bit more trawling around forums and so forth, and we discover you need to have assigned a pin to a GPIO input so it can detect the presence of a card. So we need to go, where are we? Looking here, well, SD chip select was when I thought we were going to use SPI, so that can go to GPIO input, and we will call it detect SDIO. There we go. So hopefully now we can assign that to that, and we can try compiling again. Okay, it builds. It only took 1 minute 30 seconds. That is with the screen recorder running, of course, which grabs up most of the processor power. So what I will do is fire it up and check that the at least our little USB interface is still running. We haven't done anything to that, so oh yeah, that's good. Right, so now we can start seeing if we can talk to our SD card, or at least the middleware interface to it. Onward and upward. Okay, it is now 2 days later, I think, and I have not been doing very well. So first thing, we have this detector SDIO pin, and I read that that is supposed to be pulled up to 3v3, and the SD card is supposed to pull it down to ground when the card's inserted. Not that that doesn't happen. So it was never thinking there was a card in, so in the end I forced it to think the card was in all the time by finding the appropriate function, which is board support package platform detected. That's the function. Just said it's there all the time. It will be there all the time in our application. Okay, so I've also modified our PC application, so it'll just ask for the status. It just asks it to mount the disk and comes back with whether it's mounted it or not. And I've also done a button so it'll do that repeatedly every second or so. So I can see on the oscilloscope what's going on. So let's have a look at what this oscilloscope is going to show us. So I have one probe on that, which is the write to the chip, to the SD card should I say, and this one on here, which is the read from the SD card. So let's just try doing this simple mount the disk and is it there and is it alright command to see if we can actually get anything out of our card. Right, that isn't running, so we'll run it up. And yeah, that's going. The green LED is flashing slowly. Sanity check to see if it's running. So let's, yeah, and it's alive, it's looping back. So let's start let's hit the SD status. FR not ready. So I've tried to mount the drive and it says it's not ready. And if we do that repeatedly, we get the same. So now if we look at the scope, we can see the bottom trace is the write, and the top trace is the read. So yes, it's writing something to the card, and the read is doing something. It's giving some sort of information back, or it's trying to tell us something. So does it now work? Are we getting any sense out of it? No. FR not ready. So I dug through the code, because the HAL will return one error message, the FatFT will generate an intermediate error message and then return a final error message. So digging in the code, I found this was actually a problem, that it was timing out, waiting for the reply to the command. But there we go, you can see by the top trace we are getting something out of it. So at this point I decided to give up. Is there something fundamentally wrong with my little board, which you can see by the Mozzie and Miso stuff on here is intended for SPI? So does it not work for some reason with the SDIO interface? So I am going to buy an SD card that has all the pins come out, and I don't think it's got pull-ups or anything on it. So that should be, well, I don't know, will that work any better? I really don't know, but we can try that with the SDIO interface. In the meantime, I am going to go back to plan A and try and get it to work with the SPI interface. Okay, so we've set our SPI up. SPI2 full duplex master, and the only thing I've done really is change the prescale of the baud rate to 128 for reasons I will go into later. And here are the input and output pins, the chip select and the clock, and here it is, wired up and hanging somewhat precariously in the air. And that's my little table of where it goes and what the pins are on these connectors. And this is the card plugged into the PC, and I've just put on it two little text files. That is the description out of the, or part of out of the first video, and this is just made up rubbish, which we will endeavour to read. I hope it wasn't working before, because I realised that the disc was actually empty. I hope if it had had something on the disc it would have worked. I don't think it would. So let us take the card out of there, and the PC sees it's gone, and card that goes in upside down. There we go, card inserted. So let us try and get it working and read from it. Okay, so as I said, if the FatFS is user defined, when we were using the SDIO interface we could use SD card and it all seemed to supposedly be generated automatically. Not so if we're using the user defined. So how do we connect our FatFS file system to our SPI2 port? Well, a bit of searching on the web led me to this guy's tutorial, which is very good. So I am going to leave a link in the description and you can find it from what you can see on screen here. And I'm just going to go through real quick what I did, because if you want to do it I suggest you look at this tutorial rather than me going over all the same ground again. The first thing we need to do is grab two more files which are used to talk to the SPI port, and he gives links to them and I'll copy those links in the description. And these two files are, there we go, user disk IO SPIC and user disk IO SPIH, and you download those and you drop them in the FatFS target folder, and off you go. But a few more changes yet. Right, so we have to go into the user disk IO functions, and as you can see in the, well, where are we? We go right back up. The initialize here, the status here, the read here, the write here, and the IOCTL, IO control apparently, function. We've all taken out the code that was originally in there, and we've added calls to the equivalent function in the user SPI, user disk IO SPI.c. Okay, easy enough. And another thing we need to check, you need to make sure you've called your chip select line SD_CS, because it looks for that name. If we look in main.c, yeah, it's a SD, it's defined there. Okay, we're getting there, we're getting there. I think that is all the changes we need to make. Again, check back through his tutorial, I might have missed something and I'm only going through very quickly. So now let's see if we can compile that. Okay, we've got an error, and that is in his user disk IO SPI file. You've got to include the HAL include, and he was using a STM32F3 something something, and we are using an STM32F4 something something. So we're going to do that, and we're going to build again. Okay, so that's gone through with one warning, which is something to do with a linker which I don't understand and haven't looked into, I'm afraid. Okay, shall we see if it works? So let us upload and start that code. Okay, so it's only FTDI. Are we going? Yeah, we've got a loop back, shows the code's running. So status FR OK, so it's mounted OK. So next, shall we try and read? No, we'll try and list our directory, our base directory, see what files we've got on our card. Okay, this is our message SD list function. We find first, we give it a directory object and a file info object to fill in. The third parameter is the start path, which is nothing, the base, and the fourth parameter is a filter, which I found you need to put star in if you want all of them. Again, if you look at the FatFS documentation, it'll tell you how to use those filters, but for all you need a star. Okay, and then you just find ffind next till you get no file name. Similar to the way the PC runtime library ones work, and you close at the end, close your directory at the end, and off you go. Very simple. So should we try that? Okay, ready to rock, off we go. Okay, so in here I've got SD list, which just tells it to call that function I've just described. So if we just check we're going, the loop back, we mount our disk, otherwise it won't work, and we list. Oh, look at that, it works, it works. SD card test.txt, both speedo info.txt, and system volume information. Dunno. Never mind, we won't worry about that. Right, so can we actually read those files? Okay, let's try reading. And I must admit, this FatFS seems pretty straightforward to use once you can get it to operate. We just fopen, give it a file name and tell it to read, and then we are reading text here. We're going to use all text files, I've decided. So it just fgetters just gets the line, and MSG reply just sends that line back in a message to the PC so we can print it out, and when we've done we close. Couldn't be easier. Compile it up again and run it. Okay, we're there. Then we start that, we go back into here. Okay, and we're an SD read button and a file name button, so we are gonna check we can talk to the Nucleo board. We're gonna mount our disk, we're gonna list our files. Right, well, that's our file name, so we're going to put our file name in here and we're going to read it. There we are. This is a text file. We're using it to test the STM32 access to the SD card. And I missed a space out in there. Oh dear. Right, should we try and read the other one? Put speedo info.txt. Copy that. Paste it in there, read, there we go. Amazing, it worked. How easy was that? That took me half an hour after 2 days with the SD card SDIO version. That must have taken me half an hour to get that running. Okay, so here we are. Finally got the SD card working. I did spend a lot of time trying to get the SDIO working for I haven't included very much of the video because you wouldn't want to watch it. Wouldn't want to watch me swearing at it. So that is it, I believe, for the hardware aspects. We've tried them all out and checked they work to our satisfaction. So next video we shall crack on and try and design ourselves a circuit board for this thing. Yes, fun. So until the next one, which will be on something different, it is goodbye from Triplicate. Goodbye.